Today we're looking at methods for solving quadratic equations. Now, what is a quadratic equation? Well, in its broadest sense, it's an equation which obviously has an equal sign, that makes it an equation in the first place, but it has a term in x squared in it. It may also have a term where the pronumeral is not squared, and it may have some constants as well. So, three main methods. We can either factorise, if possible, because not all of them can be factorised, but if they can, that's generally the quickest and easiest way to solve these. If we can't factorise, we've got two choices. We can use the formula, and this formula is so important in maths, it's literally just referred to as the formula. Its longer name is the quadratic formula, and you've probably seen this before. Now, a quick note about the quadratic formula. It's written on your reference sheet. So by rights, you don't really need to memorise it because you're going to have it on your reference sheet in every test and exam that you do. On the other hand, if you're using it regularly, it's sort of handy to commit it to memory because that way you can use it really quickly and easily without having to look it up. And your second choice, if factorising doesn't work or you just don't want to go that way, is you can complete the square. So in this lesson, we're looking at the first two methods, and then in the next lesson, we'll look at completing the square. Now, in the next lesson, we'll also have a look at where the formula comes from. And when we do that, I think you'll see that even though these two methods feel quite different to use, and the method is certainly quite different, using the formula is actually just completing the square, but with a shortcut. So these are very closely related. Now, first things first, if our quadratic expression is not in that form, our first step is to put it in that form. So if, for example, we're looking at something like this, we can't factorise yet. We can't use the formula yet. We're not ready to complete the square. We need to get it looking like that first. So let's get everything over on the left-hand side by subtracting 5x and subtracting 3 from both sides. And we're going to have something that then looks more like this. Now we're ready to go. So here's our same example written up on the board again. I've divided the board into two halves because I'm going to factorise this, but I'm also going to use the quadratic formula just so that we can compare the two methods and how they work. So factorising this, there's two ways that you might have. You might use the two pairs method or you might use the cross method. I'm going to do both just so I'm covering all bases with however you do it. So the two pairs method says 2 multiplied by -3 is -6. I need factors of -6 that add to -5. So I'm thinking I need +1 and -6. What do I do with my +1 and my -6? I break up that middle term, the -5x, into those two parts. So I rewrite it. There'll be 4 terms now, and it doesn't make any difference which way round my positive x and my -6x are. It'll work out the same either way, and I get that. And then on my next line, I factorise these two and factorise these two. So these ones here, if I bring an x out the front, that gives me 2x plus 1. And then I know that I need that same set of brackets over here for this method to work. So I always write those up first and then double check what needs to go here. Now to make the -6x, I need -3. And then I double check that -3 times 1 is -3. So that works. And I need my equals 0 on the end. Now I've got x of these minus 3 of them. So altogether I've got x minus 3 of them. And I get this line. Now, if you'd use the cross method, let's just do that over on the side here, then instead of these two lines, you would have just drawn up a cross and then said, right, I've got 2x and x, that's what I need to make my firsts. And then my lasts need to be -3. So factors of -3, I need 3 and 1, and one of them has to be negative, one of them has to be positive. So putting your 3 and your 1, there's really only two choices. Either it's 3 here and 1 here, or 1 and 3 the other way around. So quick inspection, you'd have your 1 there and your 3 there, and you'd say I need 6x and 1x, but the 6x has to be the negative part, and the 1x has to be the positive part. Then you put your brackets on, and that's going to get you straight to this line. So people doing this working, that avoids all of this section. Either way, you're getting to the same place here. All right, how do we continue? Well, next we need to use the null factor theorem. Remember, null means 0, nothing. Like the nullable plane, think about that. There's nothing out there. So if we've got nothing times nothing and it equals nothing, or 0 times 0 and it equals 0, then one of these two parts must have been 0. Now, a line of optional working, if you get these wrong, this is a good line for you. Either this or this must be true, right? Either this part's 0 or that part's 0. So here, adding 3 to both sides, x is 3, or 2x is -1, so x would be -1/2. So there's an optional line of working I could have put in there even. I could have written 2x equals -1. Now, if you're the kind of person that likes to show every little bit of your working and you can do it quickly, it's often a really good strategy because it avoids making mistakes. Other people will be watching this video going, that's a waste of time. I never do this whole line here. I just think that through in my head. I think, how do I make this part equal 0? This would need to be a 3. How do I make this part equal 0? This part would need to be -1, so that would need to be -1/2. Working it out in your head is great as long as you're getting it right every time. But if you find you make mistakes, often writing that line takes no time at all. You can write it as quick as think it, and then you've got all of your working there and you're sure of it. So we've got our answer here now. X is equal to 3, or x is equal to -1/2. All right, if we were using the quadratic formula, we don't necessarily need to write it down. We could have it on our reference sheet or in our memory. You can jump straight to saying what x is. So x is, let's write it down up here just so we've got it in front of us. Every time that you write it down, obviously, is another time that you're helping yourself to memorize it. We start with -b. Now, the thing that most people get wrong when they apply the formula is just making a mistake with signs somewhere. Don't forget that this part is our a, the -5 is our b, and the -3 is our c. Don't leave the negative off either of those. The sign belongs with that next digit that's in that term. So if we've got -b and b is -5, -5 is just 5. Then we've got the plus and minus part. Next, I encourage you to write out what you need to do here, but take some little shortcuts that your brain can handle. Don't throw large things into your calculator when there's potential to make a mistake. Let me explain. B squared. I look at this and I go, -5 squared. Well, I know that in my head. 5 squared is 25, and a negative times a negative is a positive. So I would write 25 down there straight away, having done that b squared part in my head. Now, a lot of people will reach for their calculator because they're a little bit lazy with something like that, and they'll type in -5 squared into the calculator. What comes out when you do that? Have a look now if you want to. Does the calculator get it right when you type it like that? No, it doesn't. The calculator says, hey, order of operations, we do indices first. 5 squared is 25. Then the calculator multiplies that 25 by the -1 that's out the front. So the calculator will return -25 if you type this in, and that's a common source of a mistake. If you put it into your calculator with brackets, then it will get it right. But we so frequently forget to put those brackets into the calculator. And that person that's just considered negative times negative is positive, 5 squared is 25, they're well ahead of you and they haven't made the mistake. So the calculator can slow you down and lead to errors. At this point, write in -4 times a is 2, I'm just going to put that in brackets, and the c is -3, I'll put that in brackets. Now I find that putting brackets around each part there also helps me avoid mistakes, because if I write a multiplication sign and then I sort of end up with a messy area with lots of signs in it, keeping things in brackets makes it really clear and easy to see what you're doing. The whole thing's over 2a, and a is 2, 2 2s are 4. On the next line, you could now reach for your calculator and throw that whole thing in. I would advise against it. 2 reasons. One is, I reckon I can work this out in my head faster than you can do it on your calculator, and if you practice, you'll be able to as well. But also, if you do this part here, just the part inside the square root bracket on the calculator or in your head, then it will be really helpful, because if this ends up turning out as a surd, we know it doesn't because we're going to get nice rational answers. But if it did come out as a surd, throwing this into your calculator would give you an answer as a decimal. And you'd also have to put it in twice to put it with a plus, and then to use your cursor and go back and get your second answer with the minus. And all of that takes time. If you know what this surd is and you can just simplify it, you can leave your answer in surd form. You've been quicker, your answer is exact, and you haven't even had to round it off. So I would recommend always just working out what's in here first. So I do this part first. -4 times 2 is -8, times -3 is +24. And 25 plus 24 is 49. Now, the square root of 49, I know, it's 7. So what I've really got is 5 plus 7 divided by 4. Well, that's 12 divided by 4, that's 3. Or I've got 5 minus 7, negative 2, divided by 4, and that's negative a half. So that extra line that you could have put in here, you could have literally written down x equals 5 plus 7 over 4, 5 minus 7 over 4. Now again, that's not silly to write that. A good way of avoiding mistakes. And as quickly as I could think it, you could have been writing it. That way, if you've got this line right, but then you make a silly mistake in your calculation and you get your answers wrong, you'll often get that extra mark for it. It might be worth 3 and you'll get 2. Whereas jumping straight to the answer and getting one of them wrong, you might only get 1. Okay, so which was easier here? Well, some people would argue that this is quicker and easier than this. Again, it sort of depends on what your method is for factorising. And some are quick and easy to factorise, like this was. Some are harder to factorise. A word of caution though, if you like this method and you're thinking to yourself, I hate factorising those non-monic quadratics, I'm just going to always use the formula, be careful. You do still need to know how to factorise a non-monic quadratic expression. Even if you're not going to use it to solve an equation where we're equaling 0, you still need to be able to factorise these things just so that you can simplify fractions and other complicated expressions that have got a quadratic expression in them. So to my way of thinking, practicing doing this, it's a good skill to have if you're not great at it already.